stationary loop in a time-varying magnetic field. So in this question, there's a coil that consists of 100 turns of wire wrapped around a square frame of size 0.25 meters. And this coil is centered at the origin with each of its sides parallel to the x or y axis. So if you define the x or y axis arbitrarily to be x, y, where we assume horizontal to be x, vertical to be y, and here they want us to find the induced EMF across the open circuited ends of the coil. And I'll get part C because they're more or less the same thing. What we want to consider is the current induced, the voltage in VEMF from the transformer and VEMF from the magnetic field. So the formula we want to talk about here is this formula from the formula sheet. And what this means is this broken down is equal to VEMF is equal to VEMF from the transformer plus VEMF from the magnetic force, which is equal to negative surface dB dt dot ds plus equal surface of C, the velocity cross product by the field divided by dl. And here, because for a time-varying magnetic field, if S is if the loop is stationary, it operates in BT only. It just means that the magnetic component of the VEMF is not present in the situation. So we don't want to consider this in the equation. From the equation sheet, we only want to care about this aspect of it, which is VEMF from the transformer. Okay, now that we have that established, we can say for this question, VEMF that we want to look at is equal to VEMF from the transformer, which is equal to the negative number of turns, d over dt s, the component of, they're asking for b dt, which is given here. So that 20 cosine x sine 2y cosine 10 3t. And here, because it is given the question that each of the sides are parallel to the x or y axis, you can have this to the side. This is 2 dx dy. Yep. Here, if you really want to relate it to the formula sheet again, this is the dB term, this is the B term, that's why we have the dt term here. So together they become, this is the dB dt term. Yeah. Okay, we're going to simplify that a little bit further. This will be equal to n is given as 100 turns, so this negative 100 ddt stays still, and then 20 times cosine we're gonna bring the constant out first, cosine 10 to the 3 t, and then because this is, we were given the question that's the sides of this, it's a square and the sides are 0.25, and this is focused on centered at the origin, which means that the left side of this will be negative 0.125, it'll be positive 0.125, right, cosine x dx, the same thing, multiplied by negative 0.125, positive 0.125, sine 2y dy will be our equation. And if this, when you calculate this, you will realize that the whole field cancels out and that there is 0 VEMF. So the VEMF across the open circuit ends of the coil would be 0.